the person who does, for instance, our attribution, so trying to figure out which marketing campaign contributed how much to our turnover, got his statistics jobs as biologists doing statistical analysis of the biology data sets. In order to feed all these 17,000 people, we need also to do actually some business. And so there's about 30 million customers, the majority in the US, with increasing parts also in Europe. For like in 2020, there was about 14 billions of value that we sold as merchandise. If you're interested in the sort of business MBA type stuff, this is a link to the investor presentation. Because we're publicly traded, there is every quarter a public statement of what we're doing and what the business actually does in detail. The locations, I personally work in the Berlin office. So this is in the top left is one of the meeting rooms we have there. And you kind of notice that it's a furniture company in that the design is really like our furniture people try to be a bit fancy there. It's quite central, so very nice to reach with public transport. We have between 700 and 1,000 people there. I'm not entirely sure anymore how many, partly because everyone's in home office now. And so keeping track of who's really an office person and who works remotely from somewhere else is not super easy. We have smaller offices around Europe, partly one in London to take care of some of the UK business, and Galway in Ireland has our main customer service type of operations for Europe. But for the sort of physicist type jobs in Europe, Berlin is really the place to go. The other place to be basically is Boston. I know there's quite a few CERN attached universities there. So you might have been there. In the Back Bay area, there is Copley Square. And in this huge building that you see in this picture is this huge office that holds several thousand people in open seating. It turns out it's not actually easy to hire enough qualified people in Boston, especially in the computer type jobs. So we're trying to also establish smaller offices in other areas. But at the moment, still, the Boston office has the most job offerings. All right. So this for the more business type technicalities. I'm not super sure. Are the audience, is this really just physicists, or do we also have people who are more involved in the CERN IT type things like running T2 sort of programming and more IT heavy stuff than just physics analysis? The chat says, yes, IT engineer.
I think we have a mixture, yes.
Yeah. So we have obviously a huge amount of computer engineers. And the thing is, well, you need to get the website running. And this requires roughly 3 types of things that we're doing. There needs to be front-end engineers to actually make the website run, what people look at when they buy something. There is a second user interface in quotation marks. And this is, we have an extranet for our suppliers to interact with us. And so a lot of the user interface work is not actually directed at people buying furniture, but at companies selling furniture with us. And so this is one big block. There is the database tier, where everything in the end needs to be stored somewhere so that we don't lose orders, so that we can send things on time. So there's quite a big chunk of database administrators and other support things there. And then there is like the programming that needs to go into, if someone clicks a button on the website to order something, a lot of processes need to be kicked off that decide, okay, this package will need to be carried by UPS instead of FedEx. And so automatically the tickets for UPS is created and sent to the transport agent to pick up at the warehouse, and all of this needs just good old programming. In part, especially at this very back end, there is some similarities that I've seen with the sort of data acquisition type of work that I've done in physics, where it's kind of important that these systems are really online 24/7, and it must not go down. So the at CMS, it was always like, if the DAQ is down, it's catastrophe. We're not taking data. Everyone needs to be called. And this sort of high reliability engineering is also there in our backends, because if the site is down and no one is buying our stuff, we're losing money instead of collision events. I'm not super deeply involved in the computer engineering part myself. There is quite a lot of jobs that I don't have really deep insight to. So the rest of the presentation will be more of the physicist type data analysis jobs where I'm working myself. So what do we actually do there? And the answer is basically everything. The whole value chain, how stuff gets sold, needs to be supported by data at every point in order to actually make this work. The thing is that Amazon is out there, and so if you're not doing things smartly, you will be crushed. And so we have not yet been crushed, which makes me think, well, maybe we're doing things fairly smartly. But it starts with pricing, where you need to forecast how many items will people buy in like 3 months, half a year. You would like to find the optimal price by trying to figure out if it's more expensive, well, fewer people will buy, but you earn more per item, or should you make it cheaper, this sort of thing. We do some computer vision to get an impression of what style our customers like, whether we have similar products to our competitors. There's a huge work on personalization. We have several million items on our website. And so it's really, really difficult for customers to actually find what they like. And a lot of work goes into trying to recommend stuff to our customers where we think that, oh yeah, this might actually be in their interest, and not just like people without balcony, and we'll try to recommend them like garden furniture. There's also on the sales and service, we try to, if you click, for instance, on our website for the customer service call number, we'll actually try to give you the number for the specialist that is most likely to be in charge of the problem that we think you might have, by looking at your past browsing behavior on our website. We do a lot of marketing, where the marketing campaigns are obviously, what do we send you in our marketing message, bidding for Google AdWords, this sort of thing, and getting the whole products organized and sorted on our website is a huge thing. What you need to bring there is kind of 3 things. You need to be able to think about the problem in a conceptual manner, get the machine learning, modeling side of things done. But this alone will not be enough. There is some solid basis in computer engineering is forever going to be necessary. And then the thing that is probably the biggest challenge that we see with people entering from academia is the business problem solving type of skills. Why are we trying to like predict the time it will take to deliver the package? How much does it really help if we implement the model that will like improve the performance of that by 10%? And so thoughts around this will really drive the success of the company. And it's something that takes getting used to. So when I entered, I was not very keen on that either, but it grows on you. Related to that, there is always some sort of technical trade-offs. that are kind of similar also to physics. So if you think about the upcoming conference timelines, you can try to do a simple analysis and get something out quickly enough. Or do you want to do fancy analysis with machine learning? How quickly can you get that to run? Is it really going to be worth it? How many more % of performance can you squeeze out of that? And is it worth your time investment? These thoughts were the question of how deep you want to go compared to how fast you want to be is quite important. And also on the engineering side, there is always thoughts about, do you first want to have the analysis chain in place and then play with the algorithms, or is it you just work on your algorithms and then afterwards you try to get the analysis chain running really well? So now I have two potential projects that we've been working with in Wayfair that you might choose from in this presentation. And one of these is the more fancy machine learning with natural language processing, which has, well, basically zero application in physics. And the other one is one that has a particle physics connection. Are there any preferences? Let me see the chat.
First answer was particle physics. Is there any way you could do both by any chance?
So not in 10 minutes. So I'll go through the particle physics one, which yeah, so the recommendation systems. So imagine you have customers, which are these 4 people there on the left. And some of these have bought some of our products. And the numbers you see in this matrix is you can put reviews on our website and you can click like 5 stars to 1 stars, how you like that. And ideally, we would like to know, for instance, for Mr. Vampire guy there at the bottom, would he like this bathtub? Given what we know about him and given what we know about our other customers. And well, normally you can just see, okay, let's see, can we find similar customers? What have they thought about the bathtub? And so if you look at that matrix, for instance, you can see that builder guy at the top has similar scores for the image and the bed. So you might think the vampire might also not like the bathtub. That's different from the wizard. The wizard didn't like the picture, but liked the bed and has a 5 score on the bathtub. So you can look at these and get a pretty good picture. The problem is that the matrix will have several millions of customers, and there is several millions of products. And like, who has written reviews or clicked the star ratings of millions of products? No one has. The matrix is super sparse. Which physics problem that you've worked on is, do you think is similar to this? Oops, I showed it by accident when looking for the chats. So this turns out to be related to unfolding in particle physics. And the thing that you do there is singular value decomposition. If you have a matrix like that, even if it's not diagonalizable and it's not symmetric, you can still do a singular value decomposition where you decompose it into 3 matrices, 2 orthonormal ones and 1 kind of diagonal one that is not symmetrical. And what you do in unfolding is then you use only the largest eigenvalues or pseudo eigenvalues of that to suppress the fluctuations that you have going between the simulated and or true space and the observed space. And this is exactly the same thing that we can do for our customer recommendations. We say that we throw away the small eigenvalues and reduce the dimensions of these auxiliary matrices there. And what this basically does is that it groups the customers into identifiable groups. So each dimension in this tables there is now belongs to people that like outdoor stuff and people that like the wood optics on their furniture. And then similar for the products, you get dimensions for comparable product groups. And so what you can do there is then to just not look at the eigenvalues, or for instance, put the eigenvalues, you split the square root of the eigenvalue, gets multiplied onto each of these dimensions. You lose the orthonormal property of the auxiliary matrices, but we're not particularly interested in this. And then you can just take these vector representations where like every dimension corresponds to one customer group or product group. And by building the scalar product, you can kind of measure the compatibility between those two. And in physics terms, this corresponds to if you have like one bin in your true distribution by doing the scalar product in these spaces there. What you measure is, does this bin in the true distribution, what's the contribution that it has from this part in the measured distribution? This is very nice because when it comes push to shove on the actual website, it helps us a lot with compute time. Finding this sort of similarity score from such a huge matrix whenever someone is on our website would take way too long. But you can pre-compute these tables. And so when you have customer U be on the website, you retrieve what you've pre-computed there. And then if you want to present some product V, you can just check what's the compatibility, should you really present that. And because it's just a scalar product, it's super fast. And all the complicated computation with the singular value decomposition is offline and out of sight. Technically, we're not doing quite the singular value decomposition that is done by unfolding, because it doesn't need to be entirely mathematically accurate. And with several million dimensions, the matrix is kind of too huge to do mathematically totally correct singular value decomposition. So what we actually do is that you just look at these dot products and the value that you have in this table and use gradient descent to just minimize the difference. And this gives you a very, very good approximation to the full singular value decomposition, but you save so much time by not looking at all the several million minor eigenvalues that you would discard otherwise anyway. It's also possible, if you play around a bit here with what is the rating and what is the terms you include. The thing is that in these matrices, not having a value because someone has not seen this product and having a 0 rating is not the same. And so going with this approximate approach also helps you a lot in that regard. So then I would like to speak a few minutes about like generic observations about how data analysis or machine learning works in business environment compared to physics. And probably one of the biggest one is that there's no Monte Carlo truth. You cannot simulate your customers. Is not possible. And so a lot of the work, the question is, where can you get suitable training samples in order to make things run? And if you're Google, you can just leverage your customers in quotation marks. So every time you have to have this I am not a robot box where you need to click like the traffic signs. This is Google trying to create Monte Carlo truth data for their autonomous driving efforts. And because there's so many people clicking on these, they get huge amounts of data. We don't have that, so we need to do other things. And one of the big ones are transfer learning approaches, where models have been trained on huge data sets that have been assembled by like Facebook. they publish the model, and then you go and fine tune that. This is a very common approach, for instance, in computer vision, where a lot of the convolutional networks that are published have been trained on just enormous amounts of data sets that were annotated in the way you see here on the right. But then if you take that and have a relatively small data set, you can still get a whole lot out of that by just tuning a little bit. You can also try to get data augmentation, where you have a relatively small data sets and you try to mix, match, and modify your examples to just get more out of that. That often works, but it's not. So if your training set is too small, you cannot go forever. It will only give you a limited factor. And the other thing is that you can try to synthesize data sets. So in natural language processing, this is super common, where you do a combination of transfer learning and synthetic data sets. The synthetic data sets is just you take available texts like Wikipedia, and you remove random words and train your model to predict the random words, which will give you a model that kind of can predict words. But then you can use that with a much, much smaller data set than all of Wikipedia to train for a specific task. So the things that you need to be aware of, or what we expect when people apply to us, is well, solid foundations. You need to know how to deal with data, how to think around complex problems, how to solve problems that you did not expect, how to manage a project that will last for longer than a few weeks, and not give up when it becomes difficult. So this point one is basically have a PhD in particle physics. On the more technical part, it is very useful to have machine learning experience. So if you just do cut-based analysis, it's unlikely that you will give a good interview, because we do in fact ask for machine learning techniques, what to do there. Data handling is important, and this is something that probably all the physicists here will handle quite well. If you do deep learning in your data analysis, this is super useful. If not, there's a lot of open material where, as hobby projects, you can train or get educated on this sort of thing. The tooling, we work a lot with Python. Is the main language, mostly because all the big machine learning libraries work with Python. I know PyTorch tried to do Lua at some point, but it did not stick. It's all Python. SQL is useful to have, but it's easy enough to pick up on the go. So before I joined Wayfair, I had zero skill in SQL. It's still not great, but good enough to pick up on the side. In general, I would not be too concerned for CERN background people to struggle with this all that much. If you would like to know more, there is, well, we have a website about ourselves as a company, which is, well, what a great company we are. We are, kind of. There's an actual tech blog where we write stuff about fun projects that we've done. And so, for instance, there is one, the NLP project that I did not talk about today, for instance, has an entry in there. I have an email address where you can contact me, and we have a career website where job offers will come up from time to time. One thing that I would probably like to say, though, even though I'm technically here to speak for Wayfair, the stuff I describe of what happens and what's the skill required will ultimately also apply for a lot of other companies that sell stuff on the internet. So if you have ever been to Berlin and looked at this old section of the Berlin Wall that has all this fun graffiti, on the other side is Zalando, which is this huge clothing retailer. And they have super similar profiles. So we have several people that we poached from Zalando, and I know also several people from us that left for Zalando. And so this is quite similar, and there is more companies out there like that. And I think that's it, and we're open for questions.
Great, thank you so much. So yeah, let's open. I see we've got Sarah who's got a question. Do you want to come on camera, Sarah, and ask your question?
Yeah, if it's possible. Can I ask a little bit about the dynamic of the data science team? You've mentioned that there are 150 people. Mm-hmm. Are there like freedom of who working on which project, or you're restricted to, for example, I don't know, somebody's doing only research-related projects, somebody's doing only NLP projects, and so on?
We're not a research shop. So in all of the career of the company, I think we've written 3 or 4 papers. So it does not work like that. The interesting part is really where you apply state-of-the-art research. So one of the big companies or academia, but Google is very prominent in that regard, is that Google writes a paper and you would think this could solve our problems. Google knows what they're doing. And so it's not always easy to reproduce what they've done. And so the most research type thing we do is typically you implement one of the super fancy machine learning type things that like Facebook or Google has written a paper about. When it comes to project choice, it's not entirely free. So it's not like you get hired to work on our transportation and transportation chain, and then decide that, oh yeah, but I would rather like to do like customer service. The thing there is that it's kind of flexible in the way that if you ask around, we can arrange for, oh yeah, for your next project, we can send you there. But this is on the timeline of months where these changes happen.
I have a question that maybe is less related to the computer science and the physics, and more about you mentioned about personalization. I did visit your website during this talk, of course, and I was curious that the growing trend nowadays is also personalization during the purchasing journey. So in the sense that there is usually a virtual assistant or some kind of a chatbot or some entity like that to help you go through the selection process of what you want to buy. I'm curious to know in your company why that's not the case, and if there is a plan to pursue that, and how would you personalize something like that?
So there is currently, we have a chatbot for service. So if something is not right, the first check will be on a chatbot. We're not having that yet on the customer selection, so this sort of variety selection sort of recommendations thing. One of the tricky parts is there that this is tricky to do for new customers. So if you're the first time on our website, it's really difficult to go somewhere with the very little data we have. I'm not sure about the chatbot project in there. My immediate question would be, how much more distraction will it be compared to not having a chatbot by just going on the site? For the other recommendations things, in general, so this happens in that we track clicks on the site. And so if you start browsing like sofas, we will try to show you more sofas, even in that one browsing session. And then if you return, well, the more data accumulates, the more relevant we can be. But I don't think there's a plan immediately for a chatbot, partly also because good chatbots are really difficult. I'm not sure on how many websites you've browsed, but I don't really think I've ever met a chatbot that has been really up to my standards. And so this would be a very large investment to get going. And I would like, well, if we go down that road, I would like to see a proper estimation of how much can we actually do with that chatbot and how much do we need to invest, because chatbots are really difficult.
Cool. We should have an offline talk about this then at some point. I'll send you an email.
Do we have any other questions from our audience? Yep, we do. Kenneth, please go for it.
Hi, Matthias. Nice to see you.
Oh, yeah.
I guess I would maybe just have a kind of generic question about your experience, and when you were searching for jobs and when you were choosing this company, how much external work you were doing really focused now on data science to actually kind of make your physics experience more applicable, and what the process was like for you to do that.
So I have to admit, I did not do any work on the side to make my physics things more applicable. I knew, so in the last 2 years or so of my physics work, I really went deep into the deep learning sort of type of analysis. But this was not specifically in order to get a perspective on industry jobs. This was mostly from the perspective of deep learning is going to be super important in particle physics analysis in the near future, and I need to get on top of that. However, the deep learning experience from physics was ultimately probably what landed me the job. So going into the interviews with Wayfair, without having done the machine learning so at the time we did the identifying the heavy boosted jets, W and Z decays hadronically with deep learning. And this experience just, so if, I don't want to say fake it till you make it. But the sort of machine learning experience you can gain from this sorts of analysis or boosted decision trees for top identification, the hands-on experience is what lets you talk more confidently about more general machine learning topics. It doesn't need to be the top quark you identify. It could be, for instance, how can you identify duplicates in your catalog? Do you sell this chair twice under different names? And having done this for physics helps really a lot to gain an understanding of other big data type applications. Even if you don't, yeah. So this worked out for me fairly well because on the physics side, I was very free to just do whatever I thought would be fit. If you're in a situation where your physics job is more structured around something that is not heavy on IT work or machine learning, this sort of thing, then it might be worthwhile to actually also do spare time projects where you think joining an open source project that does machine learning or for fun. I remember when I was still doing physics, I for fun wrote a Sudoku solver, which is not machine learning, but still at some point I had fun at programming again. And this is all things where you gather experience that can always be worthwhile. I'm not sure that answered your question, but
no, it does. I maybe a quick follow-up. I mean, I find that very interesting, and I guess you could say encouraging. But would you say that you had an easy time applying the skills and the use of deep learning that you had in physics to industry level problems, or even that when you were interviewing, the company kind of valued the general knowledge and didn't as much require that you can immediately solve problems about business with it?
So there's always a mixture where in hiring you would like to find the right balance between people with talent that you can develop and people who already know what they're doing. There's always some problem that you have, and it's super useful to have someone who can solve exactly that problem because he's done it before at some other company. This is always a risky hire because once he or she has solved that problem, there will be different problems and you don't know how they'll perform on that one. And so in hiring, we try to make the right balance between people who are smart and can pick up on things and people who know what they're doing but might not be able to do other things. I was hired mostly on this, yeah, he's smart enough and has the basics, let's see what he can do. The thing is, I mostly did natural language processing. And natural language processing is like completely different than any of the machine learning that I've done for particle physics. The concepts are notably different. There is just a lot of things that I've had zero experience with, but it worked out because, well, there's literature, you read it, there is open source code, you run it, and that works out. It's not all the positions that we have where we would like this profile, but we have these. So we hire for a mixture of smart people with potential and people with experience who have already done what we think they should do again.
Thank you. We have a question in the chat from Giordano who asks, how is the organization? Also, what's the official language of Wayfair in Germany? Is it English?
Yes, so the official language in Germany of Wayfair is English, and Germans are, if you don't look at our customer service section, Germans are not the majority of people working there. So in the data science team in Berlin, where we're about 30 people, there is, I think, 4 Germans, 5, something like that. And the rest is international. So it's a very international working environment. The organization is complicated because it's always changing. It's a very visible, growing pain of having a company that started 20 years ago and is now in the Fortune 500. This is the organization. Getting this to work from 0 to 17,000 people is difficult. And so we used to have a vertical structure where the data scientists are attached to business functions. So the NLP work was attached to merchandising. So everything that's related to the products we have on our website. And there was a different section where all the data scientists only work for instance, customer service. And this is being weakened at the moment. So we're trying to form more flexible, smaller teams that will hop from business section to business section where something is needed right now.
Thank you very much. I hope that answers your question, Giordano. I know you can't switch your mic on. Also from Vlad, there's a question. What would you say are the advantages of applying to a data science position having a physics background instead of a computer science one, since most of the applicants probably come from that sector?
So the big difference is that computer science has a proper course of study with computer science degrees, and it will always be difficult to compete with proper computer scientists on computer science jobs. 2 years ago, data science, so by now there is actually data science degrees in university that are slowly producing graduates, but at the time, data science was not an actual degree you could earn. And so the hiring was much more open for unusual backgrounds. It's also that my personal talents are more with data than with software engineering.
Thank you very much. Do we have any more questions from, yeah, we've got Sarah who's got a question. Please go for it, Sarah.
Yeah, if we have more time for one more question, yeah, I have a more generic question, not about the Wayfair, but often in interviews for data science jobs, the very first thing that they will ask me is that what type of data you are working with in CERN. And I imagine that they would like to hear something if it was tabular data or it was, I don't know, time series related and so on. And as are the data that we work in that, in CERN experiments are very specific for the high-energy physics, I find it a little bit difficult to honestly talk about it, but also find a bridge to tell them that, yeah, I have the talent to work with what type of data that you're looking for.
So,
do you have any suggestions?
We're not particularly looking for a specific type of data. So the fact that you have worked with real data is already super good. So the important part is, I would hesitate in the interview if you told me that you've only ever worked with simulation, because it's not the same as real world data. The fact that in real world physics data, there's always something to clean and something not all right, and you need to figure out what's wrong with it. This is the sort of skill that we really need, because so much can go wrong everywhere. So for instance, in our transportation data, technically you would like to know where every carton is at every point, and all our delivery guys have these scanner things. Every time they deliver something, they're supposed to scan in something. But sometimes they don't, and so there is a missing entry. And well, do you know, did the package get delivered or not? And this is the same sort of thing where, oh yeah, there's a missing hit in the tracker for this track. What do you do? And so I think the important part there is not so much exactly what data have you worked with, but can you communicate that this is useful data to have worked with? That it has properties that show up everywhere, that are challenging to master, and you have mastered it.
So I guess the fact that we are working with messy data in high-energy physics is a good point.
Yeah.
Thank you.
If whilst you're thinking of your questions, I have one for you, Matthias, if I may.
Sure.
So do you find that there are a lot of similarities between the atmosphere when you worked at CERN or when you worked in academia? Or because I have the impression here at CERN there's a lot of intellectual freedom, and you're not hemmed in too much with
so
procedures, but yeah.
So there is not the sort of total freedom in that. I would like to, well, kind of. We always think that, oh yeah, this is like the total intellectual freedom at the university, but publication pressure is a real thing. Whenever you do your work at university and you think about, can we turn this into a paper or not? This is the same thing where at work right now, I sit there, will this be profitable? And so it's not, so in hindsight, I think the university world was not as intellectually free as I thought it was, because yeah, the publication pressure and also like grant application things where, oh yeah, there is the hot topic now of whatever, supersymmetry in this and that sector. So I need to write my grant application for supersymmetry in this sector. And so this is there. It's just more explicit in that there's the profit motive instead of it is hidden under your career desires. Beyond that, is the higher up you go in the hierarchy, the more freedom there is. If you are hired as an entry-level data scientist, there is not so much, oh yeah, I would like to do the transportation. Well, no, we hired you for customer service. Where there is a lot of freedom is on the methodology. If you think that this should really be a boosted decision tree, yeah, you go for it. But if you think that, oh no, we need to do clustering with this and sort of clustering algorithm, this is then up to you. So in this sort of domain way, there is a lot of freedom.
Thank you. I see we've got a question from, is it okay, Samid, if we take Iskandar's first and then we come to you, Samid? Is
Sure,
that
no
right?
problem. Yeah.
Iskander, go for it.
Okay, maybe in this context, I mean, because you also said, how busy guys you are, how much time you have to solve the problem, for example. I mean, you understand that the people are hired for, let's say, for a specific area, let's say, like you said, transportation, and then you are, yeah, so you stay in this area, but I mean, and you're free to choose the tools. But how much time do you have? Do you also have time, let's say, to kind of tackle the problem which may appear in the future?
So that depends a lot on the project. Sometimes there is stuff where we would like to, there needs to be a band-aid to be put on the problem right away. And let's try to get something done within a quarter or half a year, and then we can iterate on the results. But then sometimes there's issues where you realize there's a minimum amount of performance that you need, and it's not going to be possible to do that in 6 months. So the first big project I was on was to figure out what are people actually talking about when they write reviews, and when they send back their stuff, what was broken. And we did a quick exploration within the first few months, and the answer was that this needs fancy tooling in order to work at the level of precision that we would like to have for the business. And at that point, the timeline immediately expands to like a year. But it depends on the problem. It's not like a quick and dirty rule of what can be done or not.
Okay, thanks. So there is also freedom. I probably also can ask for more time. So it's not like, there is more urgent. You work on some task and then people say, okay, but there is something urgent here. So probably then you need to be flexible also to do things in parallel. Okay, thanks. Matthias.
Thank you. So Samid, let's come to you, please, for your question.
Yeah, thank you again, Rachel, and thanks, Matthias. So this is more of a possibly a controversial question. So a lot of your data relies on collecting users' data, and the more they, purchase on your website, you can create a profile around that. Data privacy and data security are very prominent aspects these days. And maybe two questions would be, first is, how do you handle the reality that more and more people will be opting out of tracking, etc. in the future? And secondly, do you have ways to be still effective with data that's anonymized and not in a way that you can create individual profiles?
Yeah. So kind of and partly, we're fairly good in industry comparisons around privacy. We do not sell any of the data we collect. All stays with us. And so there's no concern there. This, on the other hand, also means that we don't have that many opt-outs. So the majority of people does actually opt in. And this is partially due to the fact that there are so many products, it's really difficult to find what you want if you don't let us help you. The other thing is there that with the people who do opt in, you are able to kind of get the sort of cohort type information that you can try to collect and then transfer that to people who opt out. There's things that you cannot opt out of. So if you actually buy something with us, you cannot opt out of us actually storing that you've bought that table with us. We need that for our accounting. And so on the legally allowable stuff, we can still kind of match you to the cohorts on which we have more details and then leverage that.
Okay, that makes sense.
And I think because we're coming up to 1 o'clock, if we've got time for one last question, we've got Kenneth who's got a question, if that's okay with you, Matthias?
Sure.
Thank you.
Okay, thanks. Yeah, another kind of sociological question. Matthias, I know you had had quite a career in physics. I mean, you were a physicist for a long time. Do you, if you think of people transitioning from physics to data science or academics to data science, do you think there's one time that's better than another? Like, would you suggest someone go after your PhD, go after a postdoc or a fellow? Or do you think it's really, when you're ready and it's not a something that you should try to optimize so much?
This is a very hard question. So my personal recommendation is every time you're looking for a new job, it should be a step up from your old job. For the exact transition, I think the PhD is still worthwhile to have. The sort of project lead type soft skills that you get from the PhD are very, very important. One of the big things that is troublesome with staying in physics longer is that one of the skills that are asked for if you want to transition at a more senior level are people management skills. So having managed people under your direct supervision is something that will be expected from you if you want to transition after a long experience in physics or anywhere else. It will be difficult to transition from like very senior physics job to junior data science job. But to get to the more senior data science jobs, it will be useful to have on your CV that, oh yeah, you've led other postdocs ideally, but also just I've supervised so and so many PhD students that I managed with my own money that I had from my own grant. This sort of you managed the grant money is something that is immediately recognized in business that, okay, this person knows how to do budgets and spend budget to be effective. Just being a researcher by yourself can be seen critically because if you compare the in business career to the university career, it's not necessarily the same skills you learn. In the academia career, you really go deep on your subject, but it's often a different subject than what's asked for in business. But having the right soft skills can still get you hired. So if you have people that you supervise in your university group, if you have responsibility for money that needs to be spent, these are all things that will be immediately appreciated and can get you more senior positions in industry.
So I think we don't have any more questions. So thank you so much, Matthias, for giving us those great insights. And I'm sure that you will also welcome people contacting you if they've got other questions that might pop up after.
Yes, very much so.
So thank you so much for that. And thank you to everybody else for joining us. And I would recommend that you connect to alumni.CERN regularly because Matthias, he posts opportunities there regularly. And you can also reach out to him through alumni.CERN and keep your profiles up to date. Very, very useful. So if we don't have any more questions, thank you so much. Thank you very much, Matthias. It was wonderful. And thank you to everybody else for tuning in on this Friday lunchtime. And bon appetit and have a nice weekend.
Thank you very much.
Thank you very much.
Bye-bye.